so let's look at some more advanced chain rule problems. These are ones that we're going to have to do multiple rules at the same time. We're going to make sure we have to identify everything first before moving on. So this question here is x squared times the square root of 1 minus x squared. So the first thing that you need to do is rewrite it. But you also need to notice this is now a product rule problem, right? We have two different things being multiplied together, so we have to consider this a product rule problem. So our derivative is going to be our first function, which is x squared, times the derivative of our second. So we've got to do the chain rule for the second part. So we bring down the 1/2, we get 1 minus x squared to the 1/2 minus 1, which is negative 1/2. We then have to multiply by the derivative of the inside. The derivative of the inside is 1 minus x squared, or excuse me, the inside is 1 minus x squared, so the derivative is going to be negative 2x. We're then done with that first part. We then have to add the derivative of the first function, which is 2x, times that of the second, which is 1 minus x squared to the 1/2. So we need to go through and simplify a little bit first before we move on. So we're going to get f prime of x. So negative 2x times 1/2 would be negative x, times this would give us negative x cubed. We then need to multiply by our 1 minus x squared to the negative 1/2. We then add on 2x times 1 minus x squared to the 1/2. So at this point, and you can see by the title up here, simplifying by factoring out the least powers. So what we can do here is we can actually factor out plenty of stuff. You take out what has the smallest power. Now look, we've got a negative x cubed, and we've got a 2x. Well, we can take out an x of the least power, which is this over here. It's a 1. So we can start off and we can factor an x out of this whole thing. But it doesn't just stop there. We also have this other part with the same base, 1 minus x squared to the negative 1/2 and 1 minus x squared to the positive 1/2. We can go in here and factor out the one with the least power, which is 1 minus x squared to the negative 1/2. Now, you may be asking yourself, why can I do that? What is going to happen? Well, when we factor out an x to the negative 1/2 away from x to the 1/2, it's a whole x to the 1, right? There's a whole exponent missing. With this one, we're taking out the same thing, so it goes away. This actually helps us factor very, very well. It's just when you learn to see it and when you learn to do it, it makes more sense. So we need to figure out what do we put inside our brackets. So what we're missing here is we're taking an x away from negative x cubed, so we should have negative x squared, and we're taking an entire 1 minus x squared to the negative 1/2 away from 1 minus x squared to the negative 1/2. So that is just to multiply by one thing. Here we're missing a 2 from our x and 2x, and we're missing an entire 1 minus x squared from the rest of this. So from here we can simplify a little bit more. We're going to get x times 1 minus x squared to the negative 1/2. And then this makes negative x squared. We're going to have negative 2x squared from over here, so we get negative 3x squared. And then you're going to have a plus 2. So you can simplify this further. The x and the 3x squared, and the 3x squared, and the negative 3x squared plus 2, you can combine those together. You can get negative 3x cubed and then plus 2x. Divide that whole thing by the square root of 1 minus x squared. We can do that and end up with a final answer. Or you could leave it a little less simplified. It just depends on your needs for the problem. But the main thing is that it becomes very complicated when you have to do chain rule while at the same time doing product rule. Product rule sets up the overall thing. Chain rule affects any individual part that has a composite function in it. Next rule. Okay, so now we have to do the quotient rule using the same type of stuff. So we've got a high and a ho, and we need to go through and figure this out. So you're going to get x squared plus 4 to the 1/3, and then times d high, which is 1, and we subtract high d ho, which is going to be x times the derivative of the bottom, which is going to be 1/3 x squared plus 4 to the negative 2/3 times 2x. And then we divide by ho, which is going to, we're going to square the denominator, and that is going to become x squared plus 4 to the 2/3. So, same thing, kind of like what we did with the last problem. We're going to factor out, we're going to attempt to factor out our x squared plus 4 to the negative 2/3. So we're going to get x squared plus 4 to the negative 2/3 on the outside. We need to figure out what's left. Okay, well, with this problem, there's an entire x squared plus 4 because the difference between these exponents is 1. So we left a whole x squared plus 4 there. So we get x squared plus 4. Then we got to figure out what the rest of this nonsense makes. So 2x, 1/3, and an x. So that's going to make 2x squared over 3. So we've got 2x squared over 3 left. And then, of course, we've got, excuse me, we then have the denominator, which is x squared plus 4 to the 2/3. So upon further simplification here, we can move this to the bottom. This is going to create in the denominator an x squared plus 4 to the 4/3. And in our numerator, we're going to have x squared plus 4 minus 2x squared over 3. So this is going to be 1/3 x squared plus 4. I would really like to simplify this more. We could turn this into 3x squared over 12, which is fine. Or excuse me, no, we can't do that. We can multiply by 3 on top and bottom. We can end up with this, or we could leave it as it was before, but again, the idea is it becomes much more complicated, and it's important to factor when we keep working with these problems. Okay, so simplifying the derivative of a power. So how do we go about this one? Well, this is a chain rule first, and then a quotient rule later. So this becomes quite a pain. Y prime, we have a squared function, and then we have an interior function here. So we respect the squared function first. And so we bring the 2 out. We have 3x minus 1 over x squared plus 3. We take 1 away from the power, so we're just left with 1. But then we have to take the derivative of the inside. And this is where we're going to have, you know, our high and ho functions. I'll do this in yellow. Okay, so set this whole thing up. So remember we have, it starts ho d high, so we've got x squared plus 3 times the derivative of the top function, which is just going to be 3. We then subtract high d ho, which is 3x minus 1 times the derivative of the bottom, which is 2x. And then we divide that by ho, which is, we'll just leave that as it was, so x squared plus 3 squared. So that is the big ugly right there. And so we just want to go through and try to simplify this as best we can. So we get 2 times 3x minus 1 over x squared plus 3. The numerator is going to simplify. Let's see, we've got this is 3x squared plus 9 minus, so remember, don't forget to multiply these. This is 6x squared. We got negative, so we got positive 1 times 2x, so we get positive 2x. So divided by x squared plus 3 squared. Well, I can do a little simplification to save myself some hassle. These two here, I'm just going to rewrite this top part a little bit cleaner. So I'm going to get negative 3x squared plus 2x plus 9. And then I can kind of combine some of this together. I can combine the denominators together to make things slightly cleaner for me. So I'm going to get 2 times 3x minus 1 times negative 3x squared plus 2x plus 9 divided by x squared plus 3. Now, because I'm going to put these together, it's to the third power, because I have 1 squared and 1 to the regular power. So you can go ahead and multiply these out as much as you want. It's a giant pain. But the idea is that you can do it, you just have to respect all the rules. Okay, so how about a repeated application of chain? So how do I look at this? The book rewrote the problem very well for us in that we have the sine cubed of 4t. Well, think about what's going on here. What are we doing to t? We're multiplying t by 4. We're then taking the sine of it, and then we're cubing it. So we've got 1, 2, 3 functions going on here. So we've got to respect the outer function, and then the inner function, and then we keep going. So we start off with the cube, and then we move on to the sine, and then move on to the 4t. So these are the 3 functions that we have to respect in order. So when we go from the outside in, you don't change anything below. It's only on the level of the cube. So the first thing that you do is you take the derivative of the cube. So you get 3 sine squared, because it's 3 minus 1. So it's 3 minus 1 of 4t. Done. Okay? So then, what we don't consider, so now we're done with the cube. So now we only pay attention to the sine. So if this was the sine of 4t, how would I go about that? Well, we have to do, what's the derivative of sine? The derivative of sine is cosine. Again, we leave the 4t alone. You don't do anything with it. We are now done with the sine. And we move on to the last part, which is our 4t. So the derivative of 4t is 4. We are done with that. So we no longer have to do any more work to this problem. We need to simplify. So the 3 and the 4 come together to make a 12. We have a sine squared of 4t, and we have a cosine of 4t. So this is, I think that the trig ones are the easiest to deal with because they just they follow a pattern and they stick together pretty well. They seem like it makes a really long single term, but that's actually not too bad to deal with. But the main thing is you have to identify the outer functions, the things that are furthest away from t. What would you do in order if you plugged into t? That's how you need to think, but in the reverse. Last question. So we're going to apply this. It says find an equation of a tangent line to the graph of f of x equals 2 sine x plus cosine x. Excuse me, cosine 2x. At the point, so we've got pi, comma 1. So our first goal here is we need to find the derivative because we need to know what our slope is. So we're going to get f prime of x. This is going to be, the derivative of 2 sine is 2 cosine x. And the derivative of cosine 2x, okay, so again, two functions now. We have the derivative of cosine, which is negative sine of 2x, and then we multiply by the derivative of the inside. So you should end up with 2 cosine of x, and then you're going to have minus 2 sine of 2x. Okay, so we're at this point. So we want to find what the tangent line is for this graph. So at the point pi 1, so we need to plug in pi into our graph. So we get f prime of pi. So that's going to be 2 cosine pi minus 2 sine of 2 pi. And so 2 cosine of pi is negative 2. And the sine of 2 pi is 0, so that ends up becoming 0. So we're just left with negative 2. So our slope is negative 2. So now we can do our formula. So we're going to get y minus y1, which is 1, equals m, which is negative 2, times x minus pi. So we get y minus 1 equals negative 2x plus 2 pi, and you'll get y equals negative 2x plus 2 pi plus 1. So we can't really combine the 1 and the 2 pi together. They're not on the same level. So we get this.